You know PowerFX inside and out. You've built dozens of Canvas apps. Yet you walk into a technical architect interview, and within 15 minutes, you've completely bombed it. The breakdown usually happens right at the start. Candidates walk in prepared to define technical terms, essentially reading the documentation back to the hiring manager. But interviewers aren't testing your memory. They are evaluating your applied systems thinking. If asked about a function and you simply give the textbook definition of patch, that's a failing answer. A passing answer describes a scenario where you chose patch over SubmitForm, explaining the strict business constraint that forced the decision. Memorizing syntax signals that you are a junior coder who knows how to type. To secure an architect role, you have to prove you can navigate real-world constraints. So how do you actually prove that? You structure every single answer using the SCCO model. This framework starts by defining the specific business scenario you faced. Then you articulate the technical choice made to address it. Next, you detail a specific technical challenge encountered, like a performance bottleneck, and finish by stating the exact outcome it had on the application. The technical interview will relentlessly test this framework across 5 distinct pillars of Canvas app architecture: UI and state, data fetching, data submission, performance, and ecosystem security. That data refuses to clear, even after the user navigates away from the screen, bloating the entire app. A seasoned architect will point specifically to context variables for these local toggles. Using Update Context Scope limits the variable scope exclusively to the current screen, dropping the memory load the second the user leaves. To push it further, you can explain how replacing global variables entirely with named formulas achieves automatic recalculation without manual state updates. Your choice of variable scope directly signals your capacity to protect application performance as the user base scales up. We can't talk about scaling without hitting the most frequently failed interview topic of all: delegation. Delegation conceptually means pushing the heavy lifting of data processing back to the Dataverse source. Instead of downloading an entire database, the fatal mistake occurs when you use non-delegable functions on large datasets. The system throws a blue underlying warning, and the app silently truncates your data at the 500 or 2,000 record limit. This is where you use the SCCO prompt. You describe the exact moment delegation caused a bug in your project and walk the interviewer through how you had to rewrite the query to restore data integrity. Neglecting delegation mechanics leads to silent data corruption, where applications surface incomplete datasets that appear functional but hide thousands of missing records. For an architect, this lack of data integrity is an immediate disqualifier. Once you've safely fetched the data, you have to write it back. This introduces an explicit choice between structured simplicity and developer flexibility. SubmitForm is highly effective for rapid operations leaning on built-in UI validation. It's safe for standard creation scenarios. But an architect knows when constraints force a switch to patch, highlighting scenarios requiring headless submission, custom UI, or complex multi-table updates. Choosing patch takes off the safety rails. You take on the burden of writing custom if-error and errors logic to capture specific data source failures and surface them to the user. Knowing how to write a patch statement makes you a developer. Knowing exactly when the business logic demands it makes you an architect. A perfectly functioning app will still fail user adoption if it takes too long to open. Perceived load time is the metric that immediately exposes a poorly architected system. The most common error is dumping heavy data fetches into app on start. This completely blocks the user from seeing the initial screen until every process finishes downloading. The architectural solution is to unblock the initial render. You shift those heavy data loading tasks to screen.onVisible, so the interface loads instantly and the data populates immediately after. When those calls do run, wrapping multiple API requests in a concurrent function transforms slow sequential loading into rapid simultaneous execution. Mastering these lifecycle events separates developers who build simple functional screens from architects who maintain sub-second response times under heavy data pressure. Up to this point, we've examined isolated technical pillars, but true mastery requires seeing how they all interact within the broader Power Platform ecosystem. Imagine a single user click. You must be able to trace how a change in UI state triggers a submission logic, which then has to safely navigate delegation limits across the network. That same action must utilize concurrent execution for speed, all while remaining strictly governed by Dataverse security roles at the bottom of the stack. This multi-layered visibility is exactly what senior technical interviewers are probing for when they ask open-ended questions. So here is your actionable playbook. Stop memorizing Microsoft documentation. Instead, create small, targeted apps specifically designed to test the edge cases of these concepts. Intentionally load a massive dataset to trigger a delegation warning. Overload an on-start property. You need to observe exactly how the raw system behaves when it breaks. Finally, write down your SCCO stories for these core pillars and practice speaking them out loud. Force yourself to articulate your architectural reasoning. Reciting lines of code will fail the interview. Proving to the hiring manager that you see the whole system is what will get you the job.